Okay, so in this video, we're going to talk about estimating square roots. And so um, we estimate square roots that are not perfect squares. So if it's not a perfect square, then we have to estimate what that number is. Whenever we have perfect squares, let's say the square root of 16, then we know that, hey, the square root of 16 is 4. But if it's the square root of 17, we don't know exactly what that number is. We have to estimate. So here's an example. If we have the square root of 17. So I'm asking you, hey, what is the square root of 17? The first way, and I want to give you two ways to estimate. The first way you can estimate is a general estimation. Okay, and the way you do that is you take the smallest, most near smallest square root, I guess you could say it like that, and then you take the next biggest. So the next smallest square root, and then you take the next biggest square root. So the next smallest square root, close to the square root of 17, is the square root of 16. And then the next biggest square root is the square root of 25. And so once you do that, you kind of got to figure out, well, what are the whole numbers that make up the square root of 16 and the square root of 25? So the square root of 16 is 4, and the square root of 25 is 5. And so what this tells us is whatever the square root of 17 is, it's going to be in between 4 and in between 5. So I can make a number line here. Because again, our number is going to be between 4 and 5. And so put 1 in the middle. That would be, this is 4, this is 5, so this would be 4.5. And then over here would be 4.1, 4.2, 4.3, 4.4, then 4.5, 4.6, 4.7, 4.8, 4.9, and that'd be 5. So it's in between these two numbers. There's one of these here. It's on this spectrum here. And so now I know that the principal root of 16 is principal root. That means what is that square? What does the square root come from? 4. The principal root of 16 is 4. The principal root of 25 is 5. And I know that the square root of 17 has to be between 4 and 5. Now I have to think about, well, which one is it closer to? And so if I look at the square root of 17, you notice that it's right after 16. And so this number is likely going to be closer to 4 than it is to 5. And so if it was halfway in between the two, I would say, well, that number is around 4.5. But since it's closer to the 4, I'm going to say that the square root of 17 is around here. Is around 4.1. Because again, this over here is the square root of 16. And this over here is the square root of 25. So I'd say that the square root of 17 is around 4.1 or 4.2. Because it's so close to the 16. And so generally, I can say, well, the approximate value of the square root of 17 is about 4. We'll put it between here. We'll do 4.15. It's about 4.1. Okay, close to 4.2, but we don't know for sure. We're just guessing. So we're not guessing. We're estimating. We're just estimating or approximating what we think the square root of 17 is. And in this case, I think it's around 4.1. And the only way to be sure is to use a calculator, but we don't have one at this point, right? And so there's another way. There's a second way we can figure this out. Okay, so this is the general way. If you're looking at a square root and you know your perfect squares, you can say, oh, that's closer to this square than that square, so it must be this number, right? So you can say, hey, this is closer to 16 than it is to 25, and the square root of 16 is 4, so this number is really close to 4, right? And so that's the number we came up with. But if you want to be a little bit more specific, again, not perfect, but a little bit more specific, there's a formula we can use. So the formula is we take the irrational square and we subtract the lower perfect square. Okay? And we're going to put that over, it's going to be a fraction. Put that over the bigger perfect square. And then you subtract the lower perfect square. Okay, so we have the irrational square minus the lower perfect square over the bigger perfect square minus the lower perfect square. So what does this look like? This is a bunch of words. What does it look like? Well, it looks like this. We have the irrational square. That means this one right here. It's irrational because it's not perfect. So we have the 17. So we're going to put 17, right? That's my irrational perfect square. Oh, I'm sorry, my irrational square, not perfect square. This is my irrational square. And then we subtract the lower perfect square. So we come over here. This is the lower perfect square. So we subtract 16. Okay, and then we make it a fraction. We put that over the bigger perfect square. So that's 25 minus the lower perfect square, so 16. So again, the irrational square, which was 17, minus the lower perfect square, which is 16, over the bigger perfect square, which is 25, minus, again, the lower perfect square of 16. The irrational square minus the lower perfect square over the bigger perfect square minus the lower perfect square. And so now we do the math. 17 minus 16 is 1. And then 25 minus 16 is 9. Okay, 1/9. And now the most important part is we take the number, this number, so that's the number it's closest to, take the 4 and we bring it down. Okay, and we bring this down here. So it's 4 1/9. So the approximate value of the square root of 17 is 4 1/9. So using this formula, it gives us the fraction. Okay, it gives us a pretty much, we're really close to figuring out where this 17, this square root of 17 is on the number line. It'll be 4 1/9. So 4 1/9 is about here. Okay, this is exactly what we thought it was, but this gives us like a mathematical approximation as to where that number is. And this is the closest we're going to get without using the calculator. And so if you were to put 1/9 into the calculator, you would get 1.1 repeating. So the square root of 17 is approximately 4.11 repeating. So 4.11 repeating. So again, 1/9 in the calculator is 0.11 repeating. And so we just added on to that whole number. And so now we have 4.11 repeating. And so that is, again, very close to what we thought it was about here. I said 4.15 initially, and so it ended up being 4.11. That's pretty close. And so, whenever you're estimating square roots, you won't be perfect because of the fact that you need a calculator. But we do have two strategies for you to use. You can generally estimate given the lower perfect square and the bigger perfect square here, right? Which one's the closest on either end? So 16 and 25, right? And then we have a number line. You can put the principal root of 4, principal root of 5, and figure out where that number goes on that number line. Or if you want to be more specific, you can use this formula, the irrational square minus the lower perfect square. And then we have the bigger perfect square minus the lower perfect square. And that gives us a fraction, which we then tie to that lower number. So we have 4 1/9, which we determined to be 4 and 1100ths, or 4.11 repeating. And we can use that number because that's the closest we're going to get to what that irrational number is without using a calculator.